This is SpaceTime, Series 28, Episode 87, for broadcast on the 24th of July, 2025. Coming up on SpaceTime, looking for an answer to one of the big questions of science, why the universe exists. A new study suggests liquid water could be forming on the surface of Mars after all, and astronomers have for the first time witnessed the dawn of a new solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have cracked open the window just a little bit on one of the ultimate questions of humanity, nothing less than why and how the universe exists. You see, the fundamental laws of physics dictate that when the universe began 13.8 billion years ago, equal amounts of matter and antimatter were created. The problem is that matter and antimatter annihilate each other when they come into contact. So, it begs the question, why didn't the universe disappear in a sudden flash of purple radiation as soon as it formed? And why is the universe made up almost exclusively of matter rather than antimatter? These questions mean there must be some fundamental difference between matter and antimatter, a difference which scientists are struggling to try and unwrap. The problem is, matter and antimatter are virtually identical to each other. Antimatter is just the same as regular matter, but with a few of its properties flipped. For every matter particle that exists, there's an antimatter counterpart. For example, the antimatter counterpart to the proton is the antiproton, and the antimatter counterpart to the electron is the positron. In both cases, these particles and antiparticles have the same mass and the same quantum spin. They both accelerate in response to forces in exactly the same way and have the same gravitational attraction. The big difference is that they have opposite electric charge. And while rare, there are very small levels of antimatter in our day-to-day existence, because antimatter is created by many types of radioactive decay, such as the decay of potassium-40. That's found in bananas, so when you eat a banana, you're eating small trace amounts of antimatter as well. Now, the amount's so small that it doesn't really affect your health, but it's still there. Now, the LHCB collaboration at CERN, the European Organisation for Nuclear Research, has reported a new milestone in science's understanding of the subtle yet profound differences between matter and antimatter. In its analysis of the huge quantities of data being produced by the Large Hadron Collider, the world's largest atom smasher, physicists have discovered overwhelming evidence that particles known as baryons, such as the protons and neutrons that make up atomic nuclei, are subject to a mirror-like asymmetry in nature's fundamental laws, which causes matter and antimatter to behave slightly differently. By the way, the Large Hadron Collider, it's a 27-kilometre underground ring below the Franco-Swiss border near Geneva. In this ring, packets of subatomic particles are accelerated in opposite directions to 99.9999% the speed of light, guided by cryogenically supercooled magnets along two beamlines. There are 4 cathedral-sized subterranean vaults where the beamlines can cross and where collisions can take place, generating the sorts of conditions that exist in the very first microseconds after the Big Bang. The new LHCB findings provide new ways to address why the elemental particles that make up matter fall into neat patterns described by the standard model of particle physics, and to explore why matter apparently prevailed over antimatter after the Big Bang. By the way, the standard model of particle physics, well, it's nothing less than the foundation stone of science's entire understanding of the universe. First observed back in the 1960s among a class of particles called mesons, which are made up of quark-antiquark pairs, the violation of charge parity or CP symmetry has been the subject of intense study in both fixed target and collider experiments. Quarks are fundamental subatomic particles. They come in 6 types or flavours, each with different masses and charge. These are known as up, down, charm, strange, top and bottom, also known as beauty. While it was expected that the other main class of particles, known as baryons, which are made up of 3 quarks, would also be subjected to the same phenomenon, experiments such as the LHCB has only ever seen faint hints of CP violation in baryons, that is until now. The reason why it took so long to observe CP violations in baryons compared to mesons is simply down to the size of the effect and the available data. Scientists needed machines like the Large Hadron Collider in order to generate large enough numbers of beauty baryons and their antimatter counterparts, and they needed an experiment capable of pinpointing their decay products. In fact, it took over 80,000 baryon decays for scientists to see matter-antimatter asymmetry with this class of particles for the first time. Now, while matter and antimatter particles are known to have identical masses and opposite charges, when they transform or decay into other particles, for example, as occurs when an atomic nucleus undergoes radioactive decay, CP violation causes a crack in this mirror-like symmetry. The effect can manifest itself in a difference between the rates at which particles and their antimatter counterparts decay into lighter particles, which physicists can then log using the LHC's highly sophisticated detectors and data analysis techniques. The LHCB collaboration observed CP violation in a heavier short-lived cousin of protons and neutrons known as the beauty lambda baryon, which is composed of an up quark, a down quark, and a beauty quark. They first sifted through data collected by the LHCB detector during the first and second runs of the Large Hadron Collider, which lasted from 2009 to 2013, and again from 2015 to 2018. They were looking for the decay of the beauty lambda baryon particle into a proton, a kaon, and a pair of oppositely charged pions, as well as the corresponding decay of its antimatter counterpart, the anti-beauty lambda baryon. Kaons are a specific type of meson made up of a strange quark or antiquark and an up or down antiquark or quark. Pions are another type of meson comprising a quark and antiquark. They then counted the numbers of the observed decays of each and looked for the differences between the two. Again, these are all very ephemeral reactions because, as we mentioned earlier, matter and antimatter annihilate each other when they come into contact. The analysis showed that the difference between the numbers of beauty lambda baryons and anti-beauty lambda baryon decays divided by the sum of the two differs by some 2.45% from zero, with an uncertainty factor of about 0.47%. Now, statistically speaking, the results differ from zero by 5.2 standard deviations. And that's important because it's above the 5 sigma threshold required to claim an observation for the existence of CP violation in this baryon decay. While it was long expected that CP violation existed among baryons, the complex predictions of the standard model of particle physics are still not yet precise enough to enable a thorough comparison between theory and what the LHCB experiment had measured. Perplexingly, the amount of CP violation predicted by the standard model is still many orders of magnitude too small to account for the matter-antimatter asymmetry we observe in the universe. And this suggests the existence of a new source of CP violation beyond those predicted by the standard model, the search for which is an important part of the Large Hadron Collider's physics program. It's a small crack in the wall allowing scientists to peer through, but not enough yet to uncover all the secrets. This is SpaceTime. Still to come, a new study suggests that liquid water could form on the Martian surface after all, and astronomers witnessed the dawn of a new solar system for the first time. All that and more still to come on SpaceTime. A new study has overturned previous ideas by suggesting it may be possible for brines of liquid water to form on the Martian surface as seasonal frosts melt. Due to extreme temperatures, dryness, and the ultra-thin Martian atmosphere, it's thought to be impossible for liquid water to form on the red planet's surface. And liquid water is a crucial precondition for life as we know it. The only hope of finding liquid water appears to be in the form of brines, which are liquids with high concentrations of salts, allowing them to freeze at much lower temperatures. But the question of whether brines can even form on Mars has yet to be answered. Now, new research reported in the journal Communications, Earth and Environment suggests it may just be possible. The study's lead author, Vincent Chevrier from the University of Arkansas, says meteorological data taken from the Viking 2 lander site on Mars, when combined with new generation computer modelling, suggest that brines can develop for at least brief periods of time during the late Martian winter and early Martian spring as a result of melting frost. Now, this challenges the assumption that Mars is literally devoid of liquid water on its surface, and suggests that similar processes may also occur in other frost-bearing regions, especially in the mid to high Martian latitudes. The data from Viking 2, which landed on Mars back in 1976, was used because it was the only mission that clearly observed, identified and characterized frost on Mars. Ices and subsurface permafrost had been seen by other missions, but not surface frost. Melting frost presents the best chances to find liquid brines on Mars. But there's a catch. See, frost on Mars would tend to sublimate quickly. That means it transitions directly from a solid into a gas without spending much or any time in a liquid state due to Mars's unique atmospheric conditions. But while sifting through the Viking 2 data, combined with data from the Mars Climate Database, Chevrier was able to determine that there was a brief window in the late winter and early spring when the conditions were just right for the formation of brines. Specifically, there was a period of 1 Martian month, roughly equivalent to 2 Earth months, when conditions were ideal at 2 points during the day, roughly in the early morning and late afternoon. Now, there is an abundance of salts on Mars, and Chevrier has long speculated that perchlorates would be the most promising salts for brine formation, since they have extremely low eutectic temperatures. That's the melting point of a salt-water mixture. Calcium perchlorate brines solidify at minus 75 degrees Celsius, while Mars has an average surface temperature of minus 50 degrees Celsius at the equator, suggesting there could be a zone where calcium perchlorate brines stay liquid. Modelling based on known data confirms that twice a day for a month in late winter and early spring, there's a perfect window in which calcium perchlorate brines can form, because that's when temperatures hover right around the sweet spot of minus 75 degrees Celsius. At other times, the Martian day is either too hot or too cold. While Chevrier's findings are not a slam dunk proof of brines, they make a strong case for the existence of small amounts on a recurring basis. Then again, even if there were direct evidence of calcium perchlorate brines detected by either a past or future lander mission, it wouldn't be in large quantities. Calcium perchlorate is only about 1% of the Martian regolith, and the frost that does form on Mars is extremely thin, far less than a millimetre thick. So it's unlikely to generate much water, certainly not enough to support human life. But it doesn't mean the planet could never have supported life adapted to a much colder, drier planet. Chevrier says the strong correlation between brine formation and seasonal frost cycles highlights specific periods when transient water activity is most likely, which could guide the planning of future astrobiological investigations. He says future robotic landers equipped with in situ hygrometers for measuring moisture content in the air and chemical sensors could target these seasonal windows to directly detect brine formation and constrain the timescales over which these liquids might persist. This is SpaceTime. Still to come, astronomers have for the first time witnessed the dawn of the formation of a new solar system. And later in the science report, researchers have created the first humans born from 3 parents. All that and more still to come on SpaceTime. Astronomers have for the first time witnessed the birth of a new solar system. The observations reported in the journal Nature has allowed scientists to pinpoint the exact moment when planets begin to form around a star. The discovery was made using the Atacama Large Millimetre Submillimetre Array Radio Telescope ALMA in Chile. What the study's authors actually observed was the creation of the first specks of planet-forming material, hot minerals just beginning to solidify. The study's lead author, Melissa Mulclure from Leiden University, says the findings mark the first time a planetary system's been identified at such an early stage in its formation. And she says that provides us a glimpse of what the birth of our own solar system would have been like 4.6 billion years ago. The newly born planetary system is emerging around HOPS 315, a protostar some 1,300 light-years away, which is being seen by astronomers as an analogue of the nascent Sun. Astronomers have often seen protoplanetary disks of gas and dust around newly formed stars. These disks are the birthplaces of planets, and occasionally they've seen newborn massive Jupiter-like planets forming within these disks. But while they knew that the first parts of planets, or planetesimals, must form at an earlier stage in these disks, they've never actually witnessed it at this early stage before. In our solar system, the very first solid material to condense near Earth's present location around the Sun is found trapped inside ancient meteorites. And astronomers have been able to age date these primordial rocks in order to determine when the clock started on our own solar system's formation 4.6 billion years ago. Now, such meteorites are packed full of crystalline minerals that contain silicon monoxide, which can condense in the extremely high temperatures that would have been present in a young protoplanetary disk. Over time, these newly condensed solid grains bind together, gradually growing bigger and bigger, initially through electrostatic attraction and then through gravity, sowing the seeds of planetary formation as they gain both more size and more mass. The first kilometre-sized planetesimals in our solar system, which grew to become planets such as the Earth and Jupiter's core, formed just after the condensation of these crystalline minerals. With their new discovery, astronomers have found evidence of these same hot minerals beginning to condense in the disk around HOPS 315. Their observations have shown that silicon monoxide is present around the baby star in its gaseous state, as well as within these crystalline minerals, suggesting that it's only now just beginning to solidify. Now, the minerals themselves were first identified using the Webb Space Telescope. But to find out exactly where the signals were coming from, the authors turned to ALMA. It was ALMA which allowed them to determine that the chemical signals were coming from a small region around the disk of a star roughly equivalent to the orbit of the asteroid belt around our Sun, about halfway between Mars and Jupiter. So the protoplanetary disk of HOPS 315 is providing a wonderful analogue for studying our own cosmic history. It'll allow astronomers to probe some of the processes that were happening during the creation of our own solar system. European Southern Observatory astrophysicist Susanna Randell says it also provides astronomers with a new opportunity to study early planetary formation by standing in as a substitute for newborn solar systems across the galaxy.
We have observed the formation of giant planets in the disks around young stars before. But now, for the first time ever, we've discovered a planet-forming system that turns the clock back even further, right to when the first specks of planet-forming material were created. Planets are born around young stars, which themselves form from giant clouds of gas and dust. These clouds collapse, and gravity from the nascent stars pulls in most of the material. The leftovers form a flat disk around the stars, a so-called protoplanetary disk. Tiny specks of dust and pockets of gas condense into solid material, and they collide and coalesce to form larger clumps, called planetesimals. Over millions of years, these grow further to finally become rocky planets or the cores of gas giants. Our Sun and its planets, including Earth, formed in exactly this way. Now, a team of astronomers have observed a new planetary system, HOPS 315, that is causing a lot of excitement in the kind of nerdy circles I move in. It appears that, for the first time ever, we're witnessing the creation of the first specks of planet-forming material, and the moment a new planetary system is born. But how exactly do we know when the clock starts ticking on the formation of a new planetary system? Well, we look for the oldest solid materials. When a planetary disk is first formed, it is extremely hot. Generally, the first things that cool down enough to solidify are crystalline minerals containing silicon monoxide. In our own solar system, these minerals are found trapped within ancient meteoroids. Many of them have not changed over time and still hold the key crystalline minerals that geologists can use to date our solar system. And the best thing? We can analyze them right here on Earth. It was by radioactively dating rocks like this that we were able to date back the birth of our solar system to 4.6 billion years ago. Back to HOPS 315. What astronomers found in this planetary system is evidence for crystalline silicates just beginning to solidify. Specifically, they found silicon monoxide in its gaseous state and within crystalline minerals around the protostar. This suggests that they are witnessing the exact moment when it turns from gas into solid, and that we are seeing the very moment when the first specks of planet-forming material are created. This process has never been observed in a protoplanetary disk before, or indeed anywhere outside our solar system, which makes this finding truly exciting. However, the initial observations gathered with the James Webb Space Telescope weren't sharp enough to figure out exactly where in the protoplanetary system the signal came from. So the researchers turned to ALMA, in which ESO is a partner, to get data with better spatial resolution. With the ALMA observations, the team were able to determine that the signal they had picked up with JWST was indeed coming from the protoplanetary disk, tantalizingly from a region close to the star, at around the same orbit as the asteroid belt is in our own solar system. So, in HOPS 315, we're seeing this material at the same distance from the star as we find rocky planets and asteroids in our own solar system. Witnessing the dawn of a new planetary system is really cool in itself. But what makes HOPS 315 even more exciting is that it appears to look very similar to what our own solar system did 4.6 billion years ago. So we can use this planetary system as a probe to find out what happened while Earth was forming and unravel our own cosmic history.
That's European Southern Observatory astrophysicist Susanna Randell. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. History has been made in the United Kingdom following the birth of 8 babies in a mitochondrial donations trial. For all practical purposes, the results are babies with 3 different genetic parents. A report in the New England Journal of Medicine says the children were born using a pioneering new IVF technique designed to reduce the risk of mitochondrial DNA disease in babies born to women who carry high levels of disease-causing mitochondrial DNA mutations. Mild cases of this disease cause problems like weak muscles, diabetes, deafness, vision loss, and heart disease. But more severe cases are fatal due to widespread organ failure. The process involves fertilizing the egg containing the disease-causing mitochondrial DNA with sperm through the usual IVF techniques. The resulting protonucleus, which contains the parent's genetic material, is then removed from the egg and transplanted into a separate donor egg, which has healthy mitochondria and has already had its original protonucleus removed. The result is an embryo with the parent's nuclear DNA, which determines the physical attributes of the baby, but also the mitochondrial DNA from the donor egg. By the way, the mitochondria is the cell's powerhouse organelle. It converts chemical energy from food intake into adenosine triphosphates, which the cell needs. Nuclear and mitochondrial DNA are thought to have had separate evolutionary origins, with the mitochondrial DNA derived from the circular genomes of bacteria engulfed by the ancestors of modern eukaryotic cells. Britain was the first country to approve laws to allow the use of this groundbreaking IVF-based technology back in 2015. It was followed by Australia in 2022. Australia now expects to begin its own trials of the new technique next year. A new study warns that the future of smashed avocado on toast might be in jeopardy because it depends on patches of native vegetation being preserved alongside farmland. A report in the journal Environmental and Sustainability Indicators claims scientists at Curtin University have revealed the hidden role of these habitats in supporting the insects which keep crops and brunch menus thriving. The authors found that the insect communities in avocado orchards adjacent to native remnant vegetation foraged on more than twice as many plant species at times when crop flowering was limited, compared to those in orchards bordered by pastures. A new study suggests that man's best friend really can judge people's characters. Many people tend to trust dogs' instinct regarding humans. If a dog gravitates towards you, dog lovers will likely see you as safe and trustworthy. But if the dogs are apprehensive around you, some people may begin to question your character. This new study, reported in the journal Animal Cognition, observed 40 pet dogs in order to investigate whether age and development influenced how they judge people. The authors first arranged for the dogs to observe another dog's interactions with 2 humans. One of these humans would be generous, giving the dog lots of snacks, while the other would not. After observing the other dog's experience, the test subject dogs were introduced to the same 2 people in order to see how they interacted with each. The results revealed that the dogs did not significantly prefer the generous person who fed the dog compared to the selfish person who refused to feed them. Now, this suggests that a dog's opinion about a human may be far more complex than previously thought. A famous Japanese psychic has issued a terrifying prophecy claiming that a catastrophic earthquake and tsunami is set to wreak havoc across the region sometime this month. Now, considering that Japan lies on a major fault zone and regularly experiences quakes and volcanic activity, it's not really all that much of a prediction. In fact, many would suggest it's stating the bleeding obvious. But as Tim Mendham from Australian Skeptic points out, lots of people are taking the claims seriously, and it's even having a real impact on local economies. The good news is, because the prediction's focused on this month, we won't have long to find out how accurate it is.
It's Ryo Katsuki, who's actually a manga artist, which is obviously a great qualification to be a psychic, but I suppose anyone can be a psychic, who has predicted major earthquakes and things upsetting in the Asia region.
Earthquakes
especially
in
actually
Japan, shock horror, that's like saying earthquakes on the San Andreas Fault, isn't it?
Yeah, that's right. Yeah, it's not exactly unknown. They are on the Pacific Ring, and they're also on what's called the Nankai Trough, so they've got double problems there. It actually has stopped a lot of tourism to Japan. A lot of people sort of not going because they're worried about this thing. So this particular psychic who supposedly, quote, correctly predicted, close quote, the deaths of Freddie Mercury and Princess Diana. Actually, every psychic predicted the death of Princess Diana. Every psychic you hear about, a lot of them are making world doom and gloom sort of predictions at the moment. Seems to be part of the mood. It won't take long to find out if this one happens. They will make an excuse for when it doesn't happen, and will it happen? I don't know. Could it happen? Yeah, of course, because it's in a place where these things do happen. But does that make it sort of likely because of a psychic says so? Well, apparently a lot of people believe it, and the tourism industry's dropped in Japan. Perhaps people even leaving to try and get away from this predicted disaster.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.